welcome back to another episode of Return DevTube. Today we're going to do something a little bit more different and a lot more interesting as opposed to all the other interviews that we've been doing in the past, as well as all the math stuff we've been doing, which I know some of you guys might be a little bit more bored of at this point. So today we're going to do something a little bit more practical, and essentially what we're going to do is we are going to create a simple LED circuit using all four of these batteries. Now, before I start, I do want to show you the voltages of each battery. Essentially, you have a 1.5 volt battery here. These two batteries are 1.2 volts, and then this one is another 1.5 volt battery. If I can only, oh, sorry about that. There you go. Now, if my math is correct, if I were to combine all these battery voltages, I should be getting 5.4 volts. Unfortunately, my brain is absolutely fried after this semester, so maybe that calculation might be wrong. But nevertheless, we shall get started. The very first thing I want to do is connect all four of these batteries, because for an LED that we're going to be using, which is essentially looking something like this, it will require a voltage magnitude of approximately 3 volts to 5 volts. And with all four of these batteries, all we really have to do is connect the negative terminal to the positive terminal end to end, and it looks something like this. Now remember, whenever you're connecting batteries, or if you ever done magnets before, you're always going to have to connect the positive to the negative for electrons to flow throughout the battery. Now, obviously, if we were to do something like this, positive to positive, that can never work since it will repel each other. And so you want the electrons to flow so that the voltage itself can flow to the LED that we're going to be working on very soon. Now this, guys, is what we're going to be using to calculate the sum voltage of the battery that we created over here. Now some of you guys might have already seen this type of instrument before. Essentially what it is a DMM, which is an acronym for digital multimeter. Essentially we use this bad boy to calculate voltages, we use it for resistance measurements, and also we use it for ampere calculation, ampere meaning current calculation. So what I'm going to do is I'm going to essentially set this up. What we're going to do is we're going to use these clips. Well, first we're going to have to connect these clips to this digital multimeter. So what we do is we take the end of one of these clips, and since we are calculating voltage, we're going to plug this over here like that. Then we're going to use this clip right here. Essentially this is used for the comp insertion right here, so we're just going to plug that in as well, just like so. And obviously we're going to be calculating voltage, so we're going to set this to voltage, and all you're really going to do is you're going to use these two clips, and we're just going to put them on one side and the other, and should read the voltage amount over there. Now in this part of the experiment, essentially what we're trying to do is trying to calculate and see what the voltage reading is for the combined battery that we created is. So all we really do is take these two clips, and then you can choose between the black or the red clip, and essentially what you're going to do is you're going to connect one of these clips to the end of either the cathode, which obviously from what I've said from before, the negative portion, negative side, or you can also connect that to the anode, which is the positive. Now you're going to end up with the same magnitude, but assuming that you do change up the direction when it comes to where you connect the actual clip, all that's really going to change is the sign itself. So what we're going to do is we're going to connect the two clips from each end of the combined batteries. So it's going to look something like this. And from when we do that, let's see what we get. Sorry about that. It does get a little difficult when you have unbalanced batteries, but bear with me please. Let's see, so we see it's approximately 5.3, 5.3, 221. Now, okay, so 5.2-ish. I'm gonna try that one more time. Okay, so 5.3, and then it gradually goes down. So that's fine. If the voltage is around that 5.2 magnitude, that's perfectly fine. Exactly what we need for this specific circuit. Perfectly fine. Okay, so in this final part of the experiment, all we're really going to do is we're going to create the actual circuit of the LED. We're going to use my best friend, the breadboard. It's been with me since junior year of high school and still with me till now. We're going to essentially be using this to circuit our LED. Now, one of the things I want to mention about the LED is the fact that if you were to look at the pin, you would notice that one of the pins is actually longer than the other. Now, why is that the case? Well, that goes back to the topics of anode and cathode. Essentially, this longer pin is known as the anode, or some may refer to as just the negative terminal, while this is referred to as, the shorter pin is referred to as the cathode, or the positive terminal. So let's circuit this up real quick. So all we're really going to do is we're just going to take this LED and we're just going to implement it onto this breadboard like so. Easy enough. And now we're going to use two jumper wires. In this case, I'm going to use this yellow and green one. I'm going to connect this yellow wire to the longer terminal, aka the anode, like so, and then I'm going to connect this green wire to the cathode of this LED, like so. And now all I'm going to do is I'm going to take these two ends of the wire and connect it. Well, essentially, I'm going to, for the longer side of the pin, I'm going to connect that to the positive side of the battery, and for the shorter side, which is the cathode, I'm going to connect that to the negative side. Now, why is that the case? Well, cathode is positive, and so you would connect that to a negative, and vice versa with an anode, which is negative, you would connect that to the positive terminal, because obviously plus or minus would be the ones that that would actually allow the flow of electrons to happen, rather than the same signed connection, which would really allow the electrons to flow. So that's how we're going to do that. So all I'm going to have to do right now is just connect the two, and when I do that, there you go. My flow of electrons are working perfectly. The voltage seems to be enough, and yeah, that is my LED.